Hello students. So today we are going to start with the chapter continuity and differentiability. Okay. So we have learned some of the concepts in standard 11. Okay. This is the continuation of that. Uh, Starting with continuity. So what is a continuous function? So there is a function defined in the textbook, that is f of x equal to 1, value is 1 if x is less than or equal to 0, and 2 if x is greater than 0. Okay, and the graph is like this. This is for 1 and this is for 0. Okay, 2. So for 1, 0 is included, right? For 2, 0 is not included. So this is not a continuous function. Why? When we are approaching from the left hand side, okay, we are getting f of x, value of f of x 1. Okay. When we are approaching from the right hand side, then the value of f of x is 2. Okay. And for continuity, we have to get the condition, that is your left hand limit should be equal to the right hand limit and the value of that function at that point. Okay. So this is not a continuous function. Another way is they say that when you draw this function on a plane of paper without lifting the pen, okay, then that is a continuous function. And here we cannot draw the graph of this function without lifting the pen. Okay, that is with one stroke you have to draw it. So this is not a continuous function. Another example they have given is this. That is for f of x equal to 1 and 2. Okay. For x equal to 0, it is 2. For x not equal to 0, it is 1. Okay. Now this function is also defined at every point. This is defined for every point. But for x not equal to 0, it is 1. And for x equal to 0, it is 2. Correct. So there are two points. So here it is given, see. Value of the function at x equal to 0 equals 2, which does not coincide with the common value of the left hand and right hand limits. So left hand it is 1, right hand it is 1. Okay. And at 0 it is 2. So it is not continuous. Okay. So the definition is given like this. Suppose f is a real function on a subset of the real numbers and let c be the point in the domain of f. Okay. Then the function is continuous at c if limit as x tends to c, f of x is equal to f of c. So the condition is if the left hand limit and right hand limit and the value of the function at x equal to c exist and equal to each other, then the function is said to be continuous at x equal to c. Okay, that is function is said to be continuous if left hand limit as x tending to c minus and right hand limit as limit tends to c plus. These two are equal to function, value of function at that point, that is f of c. If all these three are equal, then we say that it is continuous. Okay. If f is not continuous at c, we say that it is discontinuous at c. And c is called a point of discontinuity. Okay. Now there are some examples. Check the continuity of the function f given by f of x equal to 2x plus 3 at x equal to 1. Now here they have given x equal to 1. So when you take left hand limit and right hand limit, value of x remains the same, that is 1, right? So we write it as directly x tending to 1, f of x is equal to limit as x tends to 1, 2x plus 3. So now we have to substitute the value as 1. So this is 5. Now we have to check for f of x, that is f of 1. It is same, right? 5. So this is continuous at x equal to 1. Okay. Second function which is given is f of x equal to x square, and the point which is given is x equal to 0. So when you take limit as x tending to 0, limit x tends to 0, 0 square 0, and f of 0 is 0. Okay. So this is also continuous at x equal to 0. Third one is taken mod of x. Function is mod of x, and you have to check at x equal to 0. Okay. So how mod of x is defined? It is minus x for x less than 0 and plus if x greater than or equal to 0. Okay. So starting with our LHS, limit as x tends to 0 minus. Okay. So for left hand side the value is minus x, and this is given 0, so it will be 0. For RHL, 0 plus is x 0. Then they have taken one more example, that is f of x equal to x cube plus 3 for x not equal to 0 and 1 if x is equal to 0. So for x not equal to 0, uh, this is function is given by a polynomial, right? Now when we take it as to be tending to 0, it is 3. Since the limit of f at x equal to 0 does not coincide with f of 0, f of 0 is 1, and when we are taking it tending to 0, it is 3. So both are different, okay, 0 and 3. So it is not continuous. Okay. Constant function is also there. So this function is continuous at every real number. Okay. And they have taken identity function. That is, if you take f of 1, you will get 1. F of 2, you will get 2. So identity function also, it is continuous at every real number. Okay. Now another definition is a real function f is said to be continuous if it is continuous at every point in the domain of f. Now this applies for a closed interval they have taken. Okay. So at every point it has to be continuous. So you have to check for the points where a and b are there. Okay. Domain of f is singleton, f is a continuous function. Okay. So if the domain is singleton, single number, So it is a continuous function. One they have taken C. One more example for mod of x. So now they have not taken any specific value at which we have to prove f of x is continuous. Okay, they have directly asked, is it a continuous function? Okay, so according to definition, this happens. Okay, and we know that it is continuous at x equal to 0. Okay. Now we are taking one number c, okay, such that c is less than 0. Now for less than 0, we are defining f of x to be minus x. So this becomes minus c. Okay. So f is continuous at all negative real numbers. So from this we can say that f is continuous at all negative real numbers. This they are proving for two cases. That is for a negative number and for a positive number. Okay. Now they have taken the same number but it is greater than 0. Another number which is greater than 0. Okay. This is a negative number and here it is a positive number. And f of c is equal to c. Okay. For positive we will get a same number, that is c. Right. So it is continuous at all positive real numbers. Hence f is continuous at all the points. Okay. Then this is also there. This is also continuous. Okay, let's see further concepts. Every polynomial function is continuous. Okay. So function is discontinuous. When we say function is discontinuous, then first case is when right hand limit and left hand limit are not equal. Okay, this is one of the condition. Then another condition is either or both. This left hand limit and right hand limit does not exist. Okay, these are the two conditions. Then there is one more condition where left hand limit is equal to right hand limit, but it is not equal to the value of that function at that point, given point. Okay, this is called a removable discontinuity where we can remove this discontinuous point. That is, that point is removed and we make it continuous. Okay, so keep in mind these three conditions. Let's do one example. You have to find all points of discontinuity of f. Okay, and f of x is defined as x plus 3 for x less than or equal to 3 and x minus 3 if x is greater than 3. So we'll take one point, okay, where this function is continuous. So we have three conditions, right? Left hand limit, right hand limit, and the point where it is given. Okay. So left hand limit, if I take, okay, for left hand limit you have to take this x plus 3. So this is, okay. For right hand limit you have to take the function and at that point, it is at 3. So this is given x less than or equal to 3. For equal to 3, you have to take this function x plus 3. Okay, so we are getting left hand limit is not equal to right hand limit. Okay, so the function is discontinuous. and it is discontinuous at x equal to 3. Correct? Here you have to check the continuity in the interval 0 to infinity. Okay, and these functions are given. Now we have seen that it is in the textbook that every polynomial function is continuous. Okay, so both these are continuous functions, right? So this function is continuous in this interval, and this 2 minus x is continuous in 1 to infinity, right? That is 1 plus x square is continuous in the interval 0 to 1, and 2 minus x is continuous on 1 to infinity. Okay. Now we have to check uh, continuity at x equal to 1, okay, at this point. So when we approach from left hand side, okay, then we have to take the function 1 plus x square. So this answer is 2. Right hand side, when we approach from right hand side, then we have to take this function. So this is 1. So at f of here, left hand limit is not equal to right hand limit. So it is discontinuous at 1. Okay, it is continuous on this intervals, but it is discontinuous at point x equal to 1. Okay. If the function is defined as 1 upon x, okay, and x belongs to all the real numbers, then we have to check whether it is continuous or not. Okay. So if I remove 0 from this, okay, that is we write r difference 0. Okay. That is our domain. Then this function is defined. Okay. And when it is defined, we get right hand limit and left hand limit. Okay. Equal, and also the value of that function at that point. So it is continuous if 0 is removed from the domain. Okay. But if the 0 is not removed, okay, so at x equal to 0, function is not defined, right? So at this point, function is discontinuous. Okay. Graph is like this.